Day started off a day like any other day. Normal. People were joyful, running around, happy to know exactly what time it was, down to the 99.999 percentile. Until evil villain Silly Scurvy snuck up behind everyone and stole the world's only clock. This catastrophic event led to mass chaos and panic throughout the world.
Now the world will never know time again! No.
With the only clock in the world broken, and society in desperate need of time, it's up to the world's two favorite superheroes to save not only the world as we know it, but time itself.
Doc.
Hey.
We got a situation here.
Yo, I'm on like year 19. I'm almost done with H3. Can we do this in 3 days maybe?
Doc, it's the last clock in the world broke. We can't wait.
Man, these pieces are just all over the place.
Yeah, they're everywhere. Well, we should probably just start from the beginning. Alright, listen up, longitude and regulating. Here's a general diagram of how the whole escapement and regulator unit works. So, the battery is our power source, and when it's engaged with the teeth in the battery holder on the clock, it sends a current into the circuit board unit. And the circuit board, it's got a little circuitry area that's covered with some black rubber just to kind of protect the whole unit. So it's pretty easy to identify. So when the current goes from the battery onto the circuit board, it goes to the circuitry unit, which then sends a signal to the quartz crystal that vibrates the crystal at a rate of 32,768 vibrations per second, or 32,768 hertz in scientific terms. And once the crystal vibrates as many times, it sends a signal back to the circuitry counter, which then sends a signal to the digital stepper motor, an electronic signal which magnetizes the motor. And when this motor is magnetized, it's based off a copper wire unit. So when it's magnetized, there's another magnet on the bottom of our first gear, and when they're both magnetized, this magnetic field pulls the first gear around and makes it rotate, and then as soon as the signal is sent, it's gone. So the gear only rotates at a rate of 0.5 rotations per second. So as soon as the next signal is sent from the circuit counter to the digital stepper motor, it remagnetizes and turns the unit again, and the signal is lost, and so on and so on. So you're probably wondering why 32,768 hertz is the magic number for our crystal. And that's because most crystals put in clocks this size need to be very, very small. So 32,768 vibrations per second is kind of the required number of vibrations for a crystal of our size. Also, the circuitry counter works on a binary system, so it goes from 0 to 1, 0 to 1, 0 to 1, 32,768 times. And that's the same as 2 to the power of 15 is the same as 32,768 hertz. Also, just to identify some major pieces in our clock, this crystal acts as the regulator, because every time it vibrates is what identifies a second, which then sends a signal which turns the rest of the clock. The escapement is a digital stepper motor, because when it's magnetized, it turns the second hand, and when it's unmagnetized, it stops. When it's magnetized, it turns it, and so on and so on. So this controls the rotation of the second hand, and this is what identifies the period of 1 second. Alright, so here's what everything looks like on our actual clock. Here's the battery, and when it's put into this battery unit, it sends a signal through these wires, an electrical current through these wires, which then engage with these teeth on the back of the circuit board here. And here's the circuitry unit I was talking about. So when electric signal comes through here, it goes to the quartz crystal, which is in this silver cylinder right here. Once it reaches 32,768 vibrations per second, it sends a signal back to the circuitry unit, which then sends a signal up to the digital stepper motor, which consists of this copper wire and this metal piece here. So when this is magnetized, here's our first gear. A little magnet sits on the back of this. So when it's magnetized, this whole unit causes this gear to turn a half rotation. And then it comes unmagnetized, so the gear stops. 1 second later, it becomes magnetized, turns it again, and so on and so on. So when we put it all together here, this is what it looks like.
Alright, Doc. So I think I get how the electricity works. But what about the gears?
Patience, patience, Orange Dude. That's the next step.
Okay.
Alright, so first we'll talk about the second hand, because that drives the minute and the hour hands on the face of the clock. So we already learned about how this first gear rotates. There are two other gears used in moving the second hand. Okay, so as we know, the signal gets sent from the digital stepper motor, magnetizes this first gear, turns it, the signal disappears, and a second later it appears, turns this second hand again. So we take a closer look at this second hand. It has 12 teeth on it, and we already observed that it turns a half rotation per second. So 6 teeth per second are engaging with this other gear, this one right here. This gear has 48 teeth, and on the back has 8 teeth. So again, each second, 6 teeth on our first gear engage with 6 teeth on our second gear, which turns this gear 1/8 of the way around. And because we have 8 little teeth on the back of this one that engage with our third gear here, this third gear, which happens to have 60 teeth on it, is moved once per second. This gear right here is what drives the second hand on our clock face. Alright, to explain this next set of gears that drive the minute hand, I want to thank Regulady for her color coding idea of the gears. Okay, so for these gears that drive the minute hand, there's a 60:8 teeth ratio on each gear. So on the second hand here, there's 60 teeth on the bottom, 8 on top. On this intermediate hand that transfers time between the second hand and the minute hand below this black shelf, there's 60 teeth on top and 8 teeth below. So for every 1 full rotation of the red gear or the second or the second gear, this blue gear is turned 1/8 of the way around, which corresponds to a full rotation of the blue for every 8 minutes. This 1/8 rotation of the blue corresponds to the 8 teeth on the bottom of this gear, which then turn the minute hand below, engages it 1 time every minute.
Man, Doc, this stuff is getting pretty complicated, but I think I'm getting it. I don't know, this next part, just not sure if I'm going to get it. Maybe we should ask, I don't know, maybe we should ask some physics majors. Any
Good
volunteers
idea.
out there? Kevin? No? No? Okay, well,
Alright, well we'll get started.
let's do it.
Okay, so we're going to go ahead and take this unit off and see how the minute and hour hands